Hello viewers, welcome to add-on. In this question, we are asked to explain the different transistor configuration with suitable diagram. So, the transistor configurations are mainly of three types. Okay, they are CE mode, CB mode, and CC mode. CE mode is the common emitter mode. Okay, and by common, we are meaning this terminal emitter terminal is common to both the input side and as well as the output side. So in a transistor, what happens? Suppose this is the base terminal, this is the collector, and this is the emitter. Okay. We basically apply input at any one of these three terminals and we are getting the output. Suppose we are applying the input from the base terminal and we are getting the output from the collector terminal. Okay. So the emitter terminal is left out. So what happens? We will connect the emitter terminal to the ground. So the emitter terminal will become common to both the input as well as the output. So this is the C mode configuration. Similarly, we can do it like we applying the input for emitter and we are getting the output for collector and the base is common to both the input and output. So this is the CV mode of configuration. So this is the common base and similarly we can do it for collector. This is the common collector. Okay. So by common, we are meaning that this terminal, this particular emitter or base or collector terminal is common to both the input side or output side. Okay. So let us start with CV mode of configuration. So I am drawing the CV mode of configuration at first. So okay. So this is the CB mode of configuration. This is the base terminal. Okay. This will be the emitter terminal and this is the collector terminal. The base terminal is connected to the ground. This is the collector terminal. This is the collector resistance. Okay. We are getting the output from this particular portion across this collector resistance. Okay. This will be the emitter current IE. This will be the base current IB. And this will be the collector current IC. Okay. And this is the input voltage, which is V of EB, because this is the voltage between the emitter and the base terminal. And this is the output voltage, which is V of CB, which is the voltage between the collector terminal and the base terminal. Okay. So this is the input voltage because we are applying the input at this particular terminal between the emitter and the base. And this is the output voltage because we are taking the output from the collector terminal across the base and collector. Okay. So this is the output voltage. Okay. So when the emitter voltage is applied, okay, this is the VEB. As we know, this VEB junction is forward biased and the VCB junction is reverse biased. Okay. So when the emitter voltage is applied, because it is forward biased, the electrons from the negative terminal will repel the emitter electrons and the current will flow through the emitter and the base to the collector to contribute the collector current. Okay. The collector voltage, which is V of CB, is kept constant throughout the entire process. Okay. So this is the common base mode configuration. This is forward bias. As we know, this emitter base junction is forward bias and the collector base junction is reverse biased. So as it is forward biased, electrons will flow from emitter to the base. So as a result, the current flows through the emitter and the base to the collector to contribute the collector current. So IE, emitter current, is equals to IB plus IC. Okay. So this is the main configuration. So in this CV mode of configuration, the current amplification factor is defined by alpha, which is the output current by input current. Here the output current is IC and the input current is IE. Okay. So this is IC by IE. And one thing that needs to be noted, this current amplification factor is less than equal to 1 for CV mode, which is very less amplification factor because this emitter current, okay, this emitter current is responsible for the flow of electrons from emitter to the base. Now, emitter terminal, this is highly doped. The base terminal is lightly doped and the collector terminal is moderately doped. So, the electrons from the emitter terminal will go to the base, okay. But in the base, as it is, we have considered a NPN type transistor. So, in the base, the holes are present. But as it is lightly doped, the number of holes are very less. So, if we consider 100 electrons are passed from emitter to the base, only 5 electrons will recombine with the hole, which will generate the recombination current, which will be the base current. Okay. So the base current will be just 5 and the remaining 95 will contribute to the collector current. So this emitter current is almost equal to the collector current. So if we find this ratio, it will be somewhat less than equal to 1. Okay. So this is the expression of the current amplification factor in the CB mode. Now in the CB mode, similarly, let us draw the diagram. In the CE mode, which is the CE mode, this is the, so in this section, as we can see, this is the emitter terminal. Okay. This is connected to the ground. Okay. And this is the base terminal. This is the emitter terminal. This is the collector terminal. We are applying the input signal at the base terminal and the input voltage is V of B because the input is applied between the base terminal and the emitter terminal. And the output voltage is V of CE because the output is taken between the collector terminal and the emitter terminal. Okay. So here in this case, the base current is in this direction. The emitter current will be in this direction and the collector current will be in this direction. Sorry, in this direction. Okay. So just as in the CV configuration, the emitter junction is forward biased and the collector junction is reverse biased. The emitter base junction is forward biased and the collector base junction is reverse biased. Okay. And the flow of electrons controlled in the same manner. Okay. As we have understood in the CB configuration. Okay. The emitter current which is flowing, there is some amount of base current IB which is flowing to the base terminal due to electron hole recombination. As we have said earlier, this is the emitter base junction, which is the voltage between these two junctions. Okay. So when the emitter base junction is forward bias, the potential barrier between the emitter and the base is reduced. So the electrons from the emitter go to the base and the holes from the base will go to the to the emitter. Okay. And in the base, as the base is lightly doped and it is of P type, the holes will combine with the electrons, which will generate the recombination current, which is very low. So the value of IV is very low. So the here in this case, the input current is IB and the output current is IC. Since IB is very low and majority of the emitter current is passed on to the collector. Okay. So the value of the collector current is high and the value of the base current is very low. So here in this case, the current amplification factor is the output current by input current. This is the output current, this is the input current. As we have said, the value of the input current is very low and the value of the output current is very high. So here the current amplification factor beta has a value which ranges from 500 to 200, 550 to 200. Okay. The value of alpha was within 0 to 1, we can say, but the value of beta is within 50 to 200. Okay. And if we want to establish a relationship between alpha and beta, we can do it like this. Beta is equals to IC by IB and alpha is equals to IC by IE. Now we know IE is equals to IB plus IC. So if we take IB common here, we will be getting 1 plus IC by IB. Okay. So IC by IB, it will be equal to beta and IC by IB, this is again beta. So beta divided by 1 plus beta. Okay. So this is the value of So this is the relationship between the current amplification factor for CB mode to the current amplification factor in the CE mode. Okay. So next we will discuss about the last configuration, which is our CC configuration, which I am describing in the right hand side. So in the CC configuration, the collector terminal will be common to the both input and. So the configuration will be like this. Okay. This is the base terminal, this is the collector terminal, and this is the emitter terminal. Okay. And this is the input voltage, which is V of BC, because the input voltage is applied between the base terminal and the collector terminal. Okay. And this is the output voltage, which is V of EC, because it is applied between the emitter terminal and the collector terminal. And the output is taken across the, we can say across this emitter terminal, because the collector terminal is connected to the ground and the input is applied at the base terminal and the output is taken across the emitter terminal. Okay. Similarly here, the emitter junction is forward biased and the collector junction is reverse biased, and the flow of current will be controlled in the same manner. But here in this case, we can see that this is the base. So this will be the base current. This is the emitter current and this is the collector current. So the input current here is IB and the output current here is IE. Okay. So here the current amplification factor is output current, which is IE, divided by input current, which is IB. So as we know, the value of IB is very small and the value of IB and then the value of IE is very large. So the current amplification factor, which is denoted by gamma in this case, the value of gamma is very large. It is also, we can say, if the value of beta ranges from almost 50 to 200, it will also varies like same. Okay. The current gain in the CC configuration is almost same as C configuration. It is almost around 50 to 200. Okay. This is almost the same. But the voltage gain in the CC configuration is always less than 1. Okay. This is because the output voltage, we know V is equal to IR. So output voltage is equals to output current into output resistance. Okay. So the output current is IE. Okay. And the output resistance, if we denote the output resistance, it will be like RC. And the input current is IB and the input resistance is RB. Okay. So this is the output voltage and this is the output current. Okay. So why the voltage gain is very less and it is less than 1? Because the value of IE divided by IE, this is a very large value. But the value of RC and RB counterpart this IE by IB value. So this value of voltage gain is always less than equal to 1. Okay. So this is all about the 3 modes of configuration. Thank you.